You know, I am often asked, and in fact we get inquiries out of the blue at XCOR, you know, I want to be a Lynx pilot. What do I have to do? And sometimes they come from people with some pretty impressive piloting resumes, commercial pilots, some flying for major airline carriers or whatever. In the short term, though, for XCOR, our view is that nothing can replace being a graduate of a military test pilot school. Because what we're about is flight test, developmental flight test, and even early on in actual commercial operations, this is not going to be like flying a commercial airliner. It's still going to be, for much the same reasons the astronaut corps hires test pilots to be pilots of the space shuttle. That's who we're looking for. And ideally, when it comes time, and we have some thoughts in mind already, but when it comes time in the not too distant future to begin hiring other pilots, we're going to be reaching out to people with that background, perhaps even former shuttle pilots who are, can't get enough of the flying bit and still are adrenaline junkies and still want to be involved in flight test. But certainly on the development side, for a long time, it'll be test pilot backgrounds requiring a military background. However, downstream as this grows and it becomes more routine and regular, I can foresee the day where someone with a few thousand hours with a mix of jet experience, perhaps not even a test pilot school graduate, but I think it would be beneficial to have military fighter type experience just in terms of the high workloads and being upside down and pulling G's and the kinds of things you do in your profile that are not done in a commercial airliner. We would hire folks like that. But then way downstream from that, 20 years from now, when the industry may be hiring thousands, I mean, I'm really extrapolating here, but then I think we'll see people that come up through the commercial ranks having an opportunity. But in the short term, there is an abundance of people that have the right kind of background, the very stringent things we're looking for, and there are relatively few slots, whether you're talking to us or a couple of the other companies out there who have similar architectures that require pilots. Then you've got other companies that, hey, we don't need a pilot, we just automate it and do vertical takeoff, vertical landing, and that's fine. That's their architecture and their approach. Mojave and the whole area around Mojave and Edwards Air Force Base is magnificent for flight test. I mean, not just the weather, which is spectacular most days of the year, but also the airspace and the setup with the restricted areas there and the letters of agreement that can be crafted between commercial flight test enterprises and the government with Edwards Air Force Base and China Lake. So we always foresee having an XCOR presence there for flight tests as long as we're in operation. We certainly intend to expand our operating areas from there. We, of course, have the contract with and a partnership with Space Experience Curacao, who will be operating out of Curacao. And we will do that on a wet lease program initially. We're in discussions with people in Sweden, Germany, Mideast, Korea. So there's a lot of opportunities. Lynx itself will be capable of operating that from any runway that meets our technical requirements, and as long as the licensing and the particular individual national requirements are met for launch licensing, after that, sure, we can go operate there. Yeah, no problem. And we intend to. I mean, there's no reason to restrict it just to Mojave. I mean, for me, that's very convenient because it's just a 45-minute drive from home, and the view is great. California is very picturesque from altitude, but there's absolutely no restriction why we have to operate out of there, and there's a lot of good reasons to go other places too.
What is the experience of someone sitting next to you in the cockpit of the Lynx? What is that experience going to be like?
Yeah.
Can you tell me about the flight?
Sure. Well, of course, we're horizontal takeoff, horizontal landing. Think of an airplane with amazing altitude and thrust performance, okay? So takeoff in roughly 1,000 to 1,500 feet, so a very quick takeoff, not like a commercial airliner in any stretch, lots of acceleration. Get the gear up, get the nose pointed up fairly quickly so you don't overspeed the airframe, and climb it, and we're still refining this, but between a 75 and 90 degree angle. 180-second burn time, and as you get lighter and lighter, of course, the acceleration you feel goes up because there's less mass for the engines to push along. So about 3 Gs down through your chest at the end of that ascent. roughly equivalent to the way you'd feel on a shuttle launch. Then at main engine cutoff, which would be about 190,000 feet or so. From there, it's just a ballistic coast up to the final altitude, somewhere on the top side of 100 kilometers, which is 328,000 feet. And then that gives you about 4 to 5 minutes of weightlessness. Now we have the experience is side to side next to the pilot, actually offset back just a little bit for the participant. There's some technical reasons we did that, not the least of which is it gives the pilot more room to look at displays over here, and it gives us more real estate to spread things out for his cross-check. And during that weightless time, you'll have just an incredible view because it's virtually panoramic looking out the cockpit. I mean, it's not a bubble cockpit like an F-16 or an F-15, but it is very good field of view out the cockpit. We have a hot gas reaction control system, so fire little rocket motors to maneuver and establish whatever attitude we desire for the best viewing and for the experience. And then once that free fall ends, we get oriented back around in belly side down again with an angle of attack, similar to the space shuttle, about 35, 40 degrees to our relative wind, the direction you're going. And then you just set that up and you maintain that, again, with reaction control systems, so you come back into the atmosphere, and the sensible atmosphere begins to make the flight controls effective again, the aerodynamic controls. Very shortly after that point, you do need to be established for your 4G pullout, so we'll pull out and experience. This time it's G's down through the head, just like you're turning in a fighter aircraft. Four will be the nominal profile, although the vehicle will be stressed to much more. And operationally, we hold in reserve if we need to pull up to 6 Gs. We will do that to maintain below our speed limits and all the other constraints we have. But you complete that pullout, and that's going to take you down through the into subsonic regime. Lower the nose again to a much lower angle of attack, just flying along in a glider at that point, and the rest of the flight's just managing energy to get back to a runway landing. One difference we do have, we're quite similar in some respects to Virgin Galactic's Spaceship Two in that both are horizontal landing vehicles, they're piloted vehicles, they're airplane-like in many parts of their flight profiles. But one key difference we do have from that vehicle is being a liquid propellant system, and we have the option of preserving the margin of a couple seconds or whatever it takes of propellant to do a go-around if we need to. So we will have go-around capability. That's something the space shuttle does not have. It's something I believe firmly that once we get into operational service, and we're doing this over and over again, just because things happen like vehicles pull out on the runway in front of you, or weather can crump in a hurry, any number of things that you'll have to deal with. I would like us to be in an operational posture to have at least one go-around capability, light the engine, come around and land again. But whether you do that the first time around or the second time around, you go to a glided landing and stop on the runway, and you're quickly towed off. It will be designed to be minimally invasive to normal aircraft operations at a given airport/spaceport. Also recognizing that where we'll be launching will be licensed for spaceport operations. They'll have to meet certain requirements anyway, just to have anyone launch from their site. And with that in mind, we still want to minimize impact to whatever operations might be going on at whatever field we're flying out of.
It's from ignition to full stop. What's the duration of the flight? Yeah,
on Lynx 2, the full commercial operation, 35, 40 minutes. It depends in the end game. If you depending on your energy state, okay, do we dump the nose and get to a lower lift to drag and spend less time in the glide, or do we need to stretch the glide a little more? And that will vary a little bit flight to flight.
And if you're flying out of Mojave at the apogee of the flight, how far can you see?
Well, the best way to get the answer to that is this is something that your viewers can do for themselves, is just go to Google Earth, take yourself up to 100 kilometers or so, and look around. And you'll get a really good idea that from, say, Mojave, if you fly out of there, from that altitude, you can see not quite down to, but close to the tip of Baja, down to the south, all the way up the California coast, and Monterey Bay very nicely, the Bay Area, San Francisco area very nicely. And then it starts to get a little indistinct out there and as the grazing angle gets kind of low. Looking to the east, you'll be able to see the Grand Canyon quite nicely. It's a good view. You know, call it, you know, the southwest corner of the U.S.